Ben Franklin was born in 1706 and he died in 1790. We could see here that his life was punctuated by a number of major events, such as his famous kite experiment, when he moves to London, the time that he created a treaty with Great Britain. In this timeline, notice how time moves from left to right. We can also create a timeline for the Earth. See here, just as in Ben's timeline, time moves from left to right. The Earth began over here in the left, 4,600 million years ago, as did the rest of the solar system. And over here on the right side is, well, 0 million years ago. That's right now. Just as the kite experiment was a major event in Ben Franklin's life, the extinction of the dinosaurs was a major event in the history of the Earth. Where do you think dinosaurs becoming extinct would go on this timeline of the Earth? Next to which letter would you put dinosaurs becoming extinct? There are 3 ideas, 3 points, 3 concepts about the Earth's geologic timescale that I'd like to share with you. Ben Franklin's life can be marked by major events, such as his kite experiment that we mentioned earlier. The Earth is no different. As we make divisions of geologic time, we often base them on life events, such as extinctions, like the dinosaurs. Now, humans, as a human myself, I think that we're a pretty important geologic event, but we don't want to get a little too cocky. Humans have been around for a very short time, geologically speaking. Less than 1% of geologic time have humans been wandering around the Earth. The third concept is one that we've visited in the past. This is a chart of the composition of the atmosphere over time. Y-axis has the percent of gases. The x-axis is time, and notice again our time is going from left to right. 4,600 million years ago is there, the beginning of the Earth, and then right now is over here on the right side, 0 million years ago. Notice how shortly after the formation of the Earth, our atmosphere has a great deal of carbon dioxide. If you remember, that was from the process of outgassing, where volcanoes erupted and put a tremendous amount of carbon dioxide into the atmosphere. The other thing you'll notice is that the oxygen, which is in yellow here, doesn't show up until close to 2,000 million years ago. This chart is similar to the chart that we made in class back in the beginning of the year, where we see that oxygen increased over time to its current percentage of 21%. But there was a time where there was no oxygen in the air. So the third concept about geologic time is that our atmosphere has not been the same, but the composition of the Earth's atmosphere has changed over time. To get an idea of the scale of geologic time, let's revisit our earlier question. The dinosaurs became extinct 65 million years ago. 65 million is a pretty big number. How long do you think it would take you to count to 65 million? If you counted one number per second, 1, 2, 3, 4, and you went up to 65 million, how long would that take? If you wanted to count to 65 million, it would take you a little over 2 years to count to 65 million. Ooh, that'd be a while. So 65 million is a long time. But geologically speaking, the dinosaurs became extinct right there. Much closer to now, considerably closer to now than to when the Earth began. The extinction of the dinosaurs was a major event. Another major event is called the Cambrian Explosion, which happened 542 million years ago. So the Cambrian Explosion right there, 542 million years ago. By the way, if you wanted to count to 542 million, it'd take you 17 years. Before this time, in this area over here, life was simple like bacteria. 542 million years ago, the fossil record shows the appearance of many diverse life forms. There was a major change from slow, simple changes in the forms of life to rapid, complex changes. Since this was a major change, we divide Earth's history into two sections, before and after the Cambrian explosion. The part before the Cambrian explosion we call the Pre-Cambrian. During the Precambrian, there was life, but there wasn't much life, and it tended to be simple. After the Cambrian explosion, we see a large, quick change in the forms of life, as well as the complexity. You can see this division on page 8 of your reference tables. Now, you'll have to turn page 8 sideways to see this, but you'll notice we've got the beginning of the Earth at 4,600 million years ago, and then 0 million years ago. Well, there's today, there's right now. Geologic time is split up into the Pre-Cambrian, that very long time from when the Earth started, to the Cambrian explosion, where we see a very quick and large change in the diversity of life. What I'd like to do now is let's take this timeline on the right-hand side of our notes and let's fill that in with some information. Let's have the bottom of the timeline, just like it is on page 8 of your reference tables. Let's have the bottom be, that is the beginning of the Earth. And all the way up towards the top, we're going to get the Cambrian explosion. If you could put that, if you take a look at right underneath here where it says geologic time, if you follow that over, right about there is our Cambrian explosion. So from the beginning of the Earth's history to the Cambrian explosion is going to be the Pre-Cambrian. There were some major events during the Pre-Cambrian. A couple that I'd like to point out is the earliest fossils we find are right about here. So there was life during the Precambrian. It was just a little bit more simple. We mentioned earlier that the atmosphere was slowly building up with oxygen over time. The first time we see any oxygen is about that halfway mark, right about here. There was oxygen earlier. Most of the life forms were some bacteria that were producing oxygen, but that oxygen was in the oceans and didn't start showing up into the atmosphere until about then. What I'd like to do is focus our attention to this top half. Remember, the top of the line here represents right now. And let's zoom into the top section. As you see on page 8, this top section, which we call the Phanerozoic, is broken up into 3 parts: the Paleozoic, the Mesozoic, and the Cenozoic. That's 3 eras. So an eon gets broken up into an era. Let's put those on our chart. So there's our notes on the top right. On the top right of our notes, let's put those in. Would you, with the remaining time, what's left, let's draw a line that's about halfway up. This first section is known as the Paleozoic. Paleo means ancient, zoic means life. A paleontologist is someone who studies fossils in ancient life. Zoic, we also get our word zoo, meaning life. The next section up, with the remaining time, let's draw a line that is almost a quarter of that. This section is the Mesozoic. Meso means middle, as in the mezzanine section, zoic life, or middle life. And then finally, we have this last section, which is called the Cenozoic. Ceno meaning recent. The Mesozoic, that's the age of the dinosaurs. So you see we've divided up time, geologic time. There's the Pre-Cambrian, and then that top section, the Phanerozoic, we split into 3 eras called the Paleozoic, Mesozoic, and Cenozoic eras. On pages 8 and 9, we could see where the eons are split up into eras. We then could go even further. We could take the eras, such as the Paleozoic era, and we could take the Paleozoic era and we could split that up. And the Paleozoic era splits up into different periods. There's the Cambrian, Ordovician, Silurian, Devonian, Mississippian, Pennsylvanian, and the Permian. So the eras get divided up into periods, and then we can go even further than that, and we could divide up the periods into the epochs, such as the Cambrian is divided up into the early Cambrian, middle Cambrian, and late Cambrian.